Welcome to 3 Steps to Sketch. Today we're going to graph a basic cotangent graph, y equals negative cotangent of pi x. Looking at this equation, we're going to use our basic template for this because we're dealing with an unshifted cotangent graph. It's in this form, y equals a cotangent of bx. We don't have any shifting of any kind here. No vertical shifting, no horizontal or phase shifting, so we know we can use the more basic template. So let's go ahead and get started. Here's our template. In step 1, we find our essentials. We really analyze and get organized here. This step is the bulk of the work. In step 2, we'll plot our base cotangent pattern. And in step 3, we'll sketch in the graph and repeat for as many cycles as we need. All right, so here's a grid in our equation, and let's get started. Step 1 is finding the essentials. Remember, it's in this form, y equals a cotangent bx, so it should be really easy to identify a and b here. A is that leading coefficient of the cotangent function. It's got that negative out there. Understood 1, so a is negative 1. 2 comments on this. First, the a is going to help us find the y coordinates for our curve shaping points in step 2, so keep that in mind. I also like to go ahead and kind of make a star here since we have a negative value. The parent cotangent pattern, we'll see as we graph this, it's going to be flipped. So I just like to put that star there to remind myself that there will be a vertical flip or a flip over that x-axis from the typical cotangent graph. All right, so more on that later. We see b is the coefficient of x, so that's pi in this case. B tells us first how many cycles happen between 0 and pi. And it's a little weird that this isn't an integer, but it's actually nothing that difficult. Just think of pi as 3.14. And so a little bit more than 3 cycles will happen for our particular graph between 0 and pi on the horizontal axis. Okay, B also helps us find the period. Remember to calculate that for cotangent, use the formula pi divided by b. So we have pi divided by pi, our period is 1. And remember, period is just the length of one horizontal cycle. Right now that we have that, we're ready to choose how to label our axes. And it's very important with this method to be intentional about how you choose your scale. Yes, you could choose anything, but if you go the right way about it, then you'll have a really nice, neat graph where all of your key features align with your horizontal tick marks. And so I will take the period and divide by 4 to get a really nice horizontal scale value. And I do that because there are 4 key pieces that will plot in the base pattern, so they'll align nicely. All right, so 1 divided by 4, we'll be counting by 1/4 when we label the horizontal axis. For the vertical axis, you typically don't have to be as intentional. 1 usually works really well. If you like, take a look at that a value and make sure that kind of makes sense, because that, again, is going to be the y coordinate, or where we'll source our y coordinates as we plot those curve shaping points. So let's go ahead and label our axes now. For the horizontal axis, we're counting by 1/4. So we have 1/4, 2/4 reduces to 1/2, 3/4, 4/4 of course reduces to 1, 5/4. And on the negative part of the axis, we'll have all the same values, just negative. So let's go ahead and take a moment and complete this. And then we'll label our vertical axis counting by 1s. So 1, 2, 3, and -1, -2, -3. Our grid is all set up. We're almost ready to move into step 2, where we're actually starting to create the first cycle of the graph. Before we do that, let's talk about the asymptote generating equation. I like to go ahead and find this during my analysis period so that as I'm graphing, I get confirmation of the asymptotes appearing where I expect them to appear. So there's a nice little formula we can follow using our knowledge from the parent graph, y equals cotangent x. We know that the first asymptote appears on the y-axis, or x equals 0, and that the asymptotes happen once a period. And so in general, we represent that period by pi over b, and then we tack on a k. K is just an integer, and depending on what integer you substitute in, you'll get a different asymptote along the graph. So let's create our asymptote generating equation for this graph. We'll say x equals 0 plus, we know pi over b we already calculated was 1, so plus 1k. And of course you don't even have to put the 1, it's understood. Technically, you don't even have to put the 0. You could just represent it as x equals k. So substitute in a few values for k. If k is 0, we have the asymptote that happens on the y-axis at x equals 0. If k is 1, easy simplify, there should be an asymptote at x equals 1. And the same thing will follow. Let k be 2, there's an asymptote at x equals 2. K is -1, there should be an asymptote at x equals -1. So it's just a nice way to expect where your final asymptotes will fall. All right, now that we have all of our analysis done, let's move into step 2. We're going to plot the base pattern for our cotangent graph. Now remember, in general, it goes asymptote, curve shaping point, 0 or x-intercept, and then another final curve shaping point. Now a typical, we're going to go back to this a value here. We said it was negative, so we should expect a flipped graph. Remember, a typical cotangent graph looks like this, but we will be expecting ours to be flipped or reflected over the x-axis. So it's actually going to look like this pink one. Looks a little bit more like a tangent curve. Okay, and that's because of that vertical reflection. We still follow that base pattern, and we can still use that value a when we're setting our y-coordinates for our curve setting points. So let's go ahead and see how our strategy, how our method will get us the correct graph. The pink is just to show you we're anticipating what our final graph should look like. All right, we're starting with this vertical asymptote at x equals 0, this one on the y-axis. Then we have our first point happening at the horizontal tick mark, first to the right, so the 1/4, and you get the y-coordinate simply by getting our value for a, so -1. Okay, so we see it's that lower curve shaping point. Then you have a 0, that'll happen at the second horizontal tick mark, moving to the right, so 0 at 1/2. And then your final curve shaping point will happen at the third tick mark away to the right of the origin, so at 3/4, and just like normal, you get this y-coordinate by taking the opposite value of a. So the opposite value of -1 is 1. And there's that point. So we see, we haven't sketched in the graph yet, but we see that pink curve forming that we talked about. It's a reflected cotangent graph. So now we're ready for step 3. Let's sketch in this graph, and then we'll repeat the cycle, the pattern, over and over again for as many cycles as we want. So we're sketching in this graph. And here's one cycle of y equals negative cotangent of pi x. And we can repeat. So working on in the direction, the positive direction, we start with an asymptote. Notice this is the one with that asymptote equation, the asymptote generating equation. We said we expect one at x equals 1. There it is. We'd have our first curve shaping point, and of course you could continue on. I'm just going to show it continues in the established pattern. Working to the left of the origin, we'll just work the pattern backward. So we have curve shaping point, 0, another curve shaping point, and here's the asymptote we talked about that should be at x equals -1. Sketch in our curve, and we'll do one more partial pattern, show what the curve looks like, and here you have almost 3 cycles of our graph. As a final point of interest before we finish, go back to that b equaling pi. Remember we said that tells us a piece of information about the graph. It tells us that there should be pi cycles happening between 0 and pi on the graph. So we should have about 3.14 cycles happening. Now, this grid does not show nearly enough for confirming that, but this would be a really neat one to substitute into an online graphing calculator so that you could actually manipulate the axes and see that you have a little bit more than 3 cycles happening between 0 and pi. So something neat to check out. And that's really all there is to this one. Hopefully this helped you feel comfortable with 3 steps to sketch for graphing unshifted cotangent graphs. Check the video description for links to more worked out examples, and I'll put a bunch there for all the other trig functions as well. Thanks for watching.